Well, what we learned so far? We start talking about a discrete probability distribution for a discrete random variable. We learned that we can use a relative frequency histogram to visualize the data, how the data are skewed or normal. We're also interested in finding the probability using our frequency table or relative frequency graph. We did some exercises, we went over some examples. Now we're going to continue. So since we're going to use our table, relative frequency histogram, I'm going to just leave it up here. Question 4 says, now imagine that we select 3 New York City rental properties. What is the probability that all 3 rental properties we choose will each have fewer than 3 people living in them? Assume that each rental property we choose is independent from each other. Well, okay. What are we looking for? We want to know, okay, if you're looking at our data here, what is the probability? What is the probability that X is fewer than 3? Fewer than, less than 3 people. We're going to talk about this part later, that we selected 3 properties. For now, we're just going to calculate the probability that one of them has fewer than 3 people. Okay, what's the meaning of less than? It means that it's either 2 or 1. So we need to calculate the probability that X is 2 added to the probability that X is 1. We already know these proportions, these probabilities, these percentages. The probability that X is equal to 2 is 28.6%, and the probability that X is equal to 1 is 34.3%. The sum is 0.629 or 62.9%. Well, this is just for one of these properties. But question says, hey, you are selecting 3 of them. It means that we need to multiply these probabilities together. So this is 62.9% for 3 properties. You're going to just multiply these percentages together. 62.9% times 62.9% times 62.9%, which approximately gives us 0.249, which is 24.9%. So that's the difference between these two. If the question says, hey, we're just selecting one property, what is the probability that you have less than 3 residents? It's going to be 62.9%. if the question says, hey, what is the probability that all of these 3 selected properties have each fewer than 3 residents, you're going to multiply these probabilities together. So I expect you to ask, if the question says, hey, if we select 4 properties, what is the probability? You're going to multiply this percentage, this probability, 4 times by itself. So we're interested in finding the average or expected value when it comes to a random discrete variable. You need to know the mean or average or the measure of center of a discrete probability distribution can be found by the following formula. Okay, let us break this formula down. It says, hey, mu, it's like the sound of a cat, mu, which is population mean, is this symbol here is called sigma. This is sigma. It's a Greek letter representing the addition. Mu is equal to sigma or sum or addition of x times probability of x. So to find the mean, to find the center, we're going to take each x multiplied by its probability and add all together. So you can expand this formula as, if x is equal to 0, you're going to take 0 multiplied by p of 0, which is going to be 0. So we're going to start by 1. X is 1 times the probability of 1. This sigma, meaning addition, so we add. The next x is 2 times p of 2. We need to have these numbers, these values, multiply them by their x values and add. The next x value is 3 times p of 3, and we continue this process until we calculated the last x times p of that x. By adding these all together, we find the mean or the center of discrete probability distribution. So, question says, hey, now that you have this nice formula, you can easily calculate the mean of the data in previous example. Question 5 says, calculate the mean number of people in rental properties in New York City. Very well, okay. I need the data, I need the information that I had, the ones that I calculated before. Okay, one by one, we're going to solve this problem. But here, question says, hey, find the mean. To find the mean, what are we going to do? We're going to take each x value, and multiply it by its probability. So you write mean, mu is equal to the very first X value is 1. 1 times its probability, which is 36.3%. So 1 times 34.3% plus. The next X value is 2. So we're going to multiply 2 by 28.6%. 2 times 28.6% plus. Next X is 3. 3 times its probability, 3 times 17.1% plus. Next X is 4. 4 times 11.1, 11.1% plus. Next X is 5. 5 times 5.2%. Next X is 6. So 6 times 2.3%. Next X, so we'll just continue adding all of these together. 7. 7 times 1.1% plus, and the last X is 8. So 8 times 0.4%. Okay, now we have to multiply first. So you're going to multiply each of these numbers together and then add them together. The result that you get is 2 points. So after simplifying the whole thing, you get 2.38. The mean number of people in rental properties in New York City on average is 2.38. You might say, hey, 2.38, it's not very, nice number. It's decimal for using for people. So you might say, hey, on average, it's approximately 2 people. On average, so the average is almost 2 people in rental properties. So it means that the center of this data, of this distribution is around 2. The center is around 2. Here we go. The balancing point, the center is around 2. That's how we calculate the mean or the average or the center of discrete random variable probability distribution. So what we learned so far? We learned that, hey, when we have a discrete probability distribution, we can find the expected value or the average or the center or the mean of the data. We calculated the mean number of people in rental properties in New York City, which is on average is 2 people. Question 7 says, question 6 says, the mean of the discrete random variable is also called the expected value. So another name for the mean or the center is expected value. What does this tell us in the context of this problem? Well, it says on average, households in New York City consist of about 2 people. The standard deviation of the probability distribution for the number of people in rental properties in New York City is 1.4 people. So they already calculated the standard deviation for us, and they say, hey, the standard deviation is 1.4 people. How do you interpret this standard deviation? Well, remember that standard deviation is a measure of variability. It gives us a number, a value that helps us to calculate, to interpret the variability on average from the mean. So the answer to this question can be, hey, we expect that the typical randomly selected household to be different in size from the mean by about 1.4 people. That's the meaning of standard deviation. So we randomly select a household. We expect that the size of that randomly selected household be different from the mean by 1.4 people. Okay, question 8 says, hey, now let's explore the relation between probability and the area. In the previous probability histogram, the width, let's take a look at the graph that we have here. The width of each bar is 1. So the width of each bar is 1. What is the area of the bar centered at 1? Remember that to calculate the area of a rectangular shape, we multiply the width by its length. So the area is width times the length. We know that the width, the measure of the width is 1 unit. For simplicity, we use 1 unit. So this is 1 unit times its length. The length is 0.343. So it's going to be 1 times 0.343, which is 0.343, or as you can see, it's 34.3%. The area of the first bar centered at 1. So by this logic, the area is the same as probability. I expect you to ask, okay, now what is the area of the second bar? We know the width is 1. So it all depends on the length. The length is 0.286 or 28.6%. The length is 28.6%. So if I multiply 1 unit by the length, which is 28.6%, the area is going to be the same as probability. Well, we can continue this process. Adding all of these probabilities, note that the width is 1. That's why we just focus on probabilities as the area. Adding all of these together gives the total area of this probability distribution histogram. So let us continue. Let's move on to the next page. Here we go. Question says, well, what is the area of the bar centered at 2? We already answered this. We know that the bar is width times the length. The length is 0.286, so it is the same as its probability, 28.6%. Question says, hey, now what is the relationship between a value's area and its probability? As we see, the area and probability, they are the same. They are the same. So now part D of the question says, well, now that you know each of these areas, what is the sum of all of these areas? If we add this together, it means that we are adding 0.343 plus 0.286 plus 0.171 plus 0.111 plus 0.052 plus 0.023 plus 0.011 plus 0.04. If we add all of these numbers together, it is equal to 1. The sum of all of these numbers is equal to 1. In statistics, we usually say that it is 100%. 100% and 1 are the same thing. So the area below the graph is 100% or 1 unit. So let's take a look at question 9. Question 9 says, well, okay, a college student is about to purchase a car. When the salesman recommends that he should sign up for a protection plan. Under this plan, the student will pay an additional $20 per month. So $20 per month to cover the costs of oil changes, routine maintenance, and any major repairs. The protection plan provides coverage for the first 5 years of ownership. On average, the student drives 12,000 miles per year. 12,000 miles per year. He's very responsible and will get an oil change every 5,000 miles. The average cost of an oil change is $30. So these are the information that we have here. Every 5,000 miles, the owner will do the oil change, which is $30. What is the cost of oil changes for the first 5 years if the student doesn't accept the protection plan and pays for his own oil changes? So in a word, you're trying to calculating that if paying for $20 per month to cover the costs of oil change, routine maintenance, and any major repairs, is it beneficial for the person, or that person is paying extra money? So suppose you go to a dealership and try to buy a car, and they say, hey, now that you purchased this car, let's, purchase a protection plan, $20 per month. You might say, hey, $20 per month, okay, that's a good deal. Let's do it. But before accepting that, try to calculate what would be your cost. Does it make sense to pay $20 per month? Or it makes sense to do it yourself and save some money? Okay, what is the cost of oil changes for the first 5 years if the student decides to do everything himself? The expected cost is the next step that we're going to do. But first, how do we calculate the cost of oil changes for the first 5 years? So remember that question says, hey, on average, the student drives 12,000 miles per year. So we're going to have 5 years, 12,000 miles per year times 5 years, which gives us 60,000 miles in total of 5 years. At the same time, what do we know? We know that after each 5,000 miles, the student has to pay $30. Okay, so 60,000 miles in total. Total miles divided by 5,000 miles for each oil change. How many oil change do we get? We get 12 oil changes. Each oil change costs $30, so 12 oil changes times $30, which is $360 for 5 years. So the student needs to pay $360 in 5 years for oil changes. In 5 years. Okay. So now think about it this way. The plan costs $20 per month. $20 per month. Okay. So in 1 year, the student has to pay $240. In 5 years, the student needs to pay $360. So which one makes sense? Does it make sense to accept the plan or take care of the car himself? Very well. So let us move on to next step. Part B says, well, we have these information here. In the probability distribution below, you can see the potential cost of routine maintenance and possible major repairs in the first 5 years of car ownership. Oil changes are not included in the cost. So now let us take into account other factors that might be important to you to accept that $20 per month plan. Not oil changes, but maintenance and repair costs for the first 5 years. You might say, hey, even though in previous one, we calculated that, okay, the oil changes cost is going to be $360 in 5 years, but I might end up with, repairing my car, paying extra for maintenance, and so on. Well, as a statistician, you need to ask about, okay, what is the probability distribution for annual maintenance and repair costs for the first 5 years of the car? Then do the calculation. It says, okay, annual maintenance and repair costs for the first 5 years, which is denoted by X. X is the cost for the first 5 years. If X is 0, the probability is 19%. If the cost is $500, the probability of the cost to be $500 is 67%. If the cost is $1,000, if you ended up paying $1,000 for your maintenance and repair costs, the probability is 9%. Well, the probability that you pay like $1,500 for maintenance and repair is going to be 4%. And if you ended up paying $2,000 for the cost, the probability is just 1%. It's very small. So you must be very, very unfortunate to end up paying $2,000 for maintenance and repair costs in the first 5 years. The probability is very small. It's just 1%. Question says, hey, okay, now that we have this information, what is the average cost or expected value of the routine maintenance and possible major repairs for the first 5 years? Again, remember that in previous question, we only calculated the costs for oil changes in 5 years. Now we are interested in calculating the average cost of routine maintenance and possible major repairs for the first 5 years. It helps us to make an informed decision to accept $20 cost per month or not. Well, okay, so the calculation, you're the statistician, you already know how to calculate everything. What are we going to do? We're going to follow the formula, mu equals to the sum x times px. So the mean is equal to, the very first x is 0, 0 times 19% plus the second x is 500 times its probability, which is 67% or 0.67. The next x value is 1,000. 1,000 times its probability, which is 9%, plus the next x value is 1,500 times its probability, which is 4%, plus the last one, which is $2,000 times its probability, which is just 1%. Well, okay. It is about, so after multiplying all of these numbers together, adding them to each other, it's going to be $505. Okay, so we expect to pay $505 in 5 years for our car. Let us add the cost of oil change as well. So the cost of oil changes in 5 years is going to be $360 plus the maintenances, $505 maintenance. This is about, okay, $865 in 5 years. So we expect to pay $865 for oil changes and maintenance or major repair in 5 years for our car. Okay, as you can see, it's larger than the initial amount of $360 for oil changes. We need to take into account the maintenance as well. So in total, we expect to pay $865 in 5 years. Now, what is your decision? Does it make sense to purchase the protection plan or not? Okay, to do that, let us calculate the protection plan cost. Protection plan says, hey, it is $20 for each month, but in 5 years, we have 60 months. It gives us $1,200. So if you were to pay for the protection plan, you end up paying $1,200. But if you decide not to take the protection plan, you expect to pay $865 in 5 years. So as you can see, the protection plan in 5 years is more expensive than taking care of your car yourself. Okay. According to Social Security Administration period life table, the probability that a 70-year-old male will die within 1 year is about 0.018 or 1.8%. The cost of a 10,000 life insurance policy for a 70-year-old male from one insurance company is about $540 per year. John is a 70-year-old male. He paid the company $540 at the beginning of the calendar year for a $10,000 life insurance policy. Well, how much money did John pay the insurance company? If he dies this year, how much money will the insurance company pay his beneficiaries? If John dies this year, how much money will the company lose on this policy? What is the probability John will die during the year? If John leaves for the entire year, how much money will the company make on this policy? And finally, what is the probability that John will live for the entire year? So remember that different companies, they have access to a huge data about the possibilities or probability that a person die in different ages. So depending on medical condition of the person and so on, they collect the data based on their customers that they gather throughout years. So when you see probabilities like this, it means that they already have the data, and based on those probabilities, they make these policies. So we're a statistician. We're interested in doing a little bit of calculation. How much money did John pay the insurance company? Okay. We have this information here. John is a 70-year-old male and is about $540 per year. So John paid $540. So the answer here is $540. If he dies this year, how much money will the insurance company pay his beneficiaries? Well, this is obvious. It says it is going to be $10,000. So $10,000. These information are given to us in this problem. B says, well, if John dies this year, how much money will the company lose on this policy? So they are paying the beneficiaries $10,000 and they only earned $540. So it's going to be $10,000 minus $540. It's going to be $9,460. The company will lose this amount of money. Question says, hey, what is the probability John will die during the year? We're going to take a look at the first and second line because we have information about the probability that a 70-year-old male will die within 1 year, which is about 1.8%, 0.018 or 1.8%. If John lives for the entire year, how much money will the company make on this policy? Okay, it means that they don't have to pay beneficiaries $10,000 and they earned $540. So it's just going to be $540. Question says, well, what is the probability that John will live? Okay, live for the entire year. We know that the probability that John will die in 1 year is 1.8%. But what is the probability that he will live? It's going to be 100% minus 1.8%, or it is 1 minus 0.018, which is 0.982 or 98.2%. Now I expect you to ask, well, what is the expected value? Based on the policy, what is the expected value? In this case, we're going to construct our table. And try to answer these questions. Let X represent the amount of money that the insurance company will earn this year from John's policy. When the company loses money, the amount of money earned is negative. It means that it has a negative sign in front of it. Construct a discrete probability distribution for X by completing the following table. Amount of money earned by insurance company X if in the case that John dies this year. How much they earn? They don't earn anything. Remember that. They lose money. So it's going to be negative 9,460. If John lives the entire year, they don't have to pay anything to the beneficiaries. So they only earned 540 and they don't lose anything. The probability, we know that the probability that John dies this year is 1.8% or 0.018, and the probability that John lives the entire year is going to be 0.982 or 98.2%. Well, what is the expected value? To find the expected value, we multiply X by P of X and add them together. So mean is equal to negative 9,460 times its probability, 0.018, plus X, which is 540, times its probability, 982. It gives us $360. So the insurance company will make an average $360 per customer.